All right, Chem, today we're going to learn about limiting reactants and percent yield. So percent yield can relate to stoichiometry and it can relate to limiting reactants. What is the maximum yield? What is the theoretical yield? Those are the kind of words that were thrown around, and we're going to clarify what they mean today. So our theoretical yield is the maximum amount of product that could be formed from given amounts of reactants. So anytime you are doing calculations on a piece of paper, that is what we call theoretical yield. So theoretically, in a perfect world, this is how much we should have produced. So anytime you're doing stoichiometry on a piece of paper, that's going to be your theoretical yield. Actual yield is the amount that you collect or gather or recover from the laboratory situation and the theoretical yield. So actual yield can be reduced by factors that are out of our control. So these are not mistakes. Whenever you have error in the lab situation, an error is not the same as a mistake. So when you're talking about sources of error, you don't want to say, oh, I didn't measure carefully, or my glassware wasn't clean before I started my lab. Those are not error, those are mistakes. Error are things that we can't really control. For example, there's a lot of chemical reactions that do not 100% go to completion, or it takes so long to go to completion that we don't see all the products. We don't have any control over that. There's also the possibility that your reactants aren't 100% pure. That means that I order some stuff from the laboratory supply and they have different grades, believe it or not. So I can pay a lot of money to have super pure reactants. But in chemistry class, that's not really necessary. So we simply use a lower grade of laboratory grade. There's also food grade. There's all sorts of different grades of chemicals. But if you're doing a chemical reaction from things in nature, those are often contaminated. And again, that's not anything that's within our control. The other thing is a lot of chemical reactions give off gases. Well, those gases can be hard to collect. So you're going to lose some of them to the atmosphere, and that's just the way life goes. There's also could be side reactions. There could be something around that the chemical you want to reacts with instead. And there's also reversible reactions that a lot of the reactants stay as reactants instead of turning to products. And that's going to reduce the amount of products that you get also. So there's all sorts of things that happen in nature that are out of our control that reduce the amount that we actually produce. So the percent yield is the ratio of the actual yield to the theoretical yield expressed as a percent. So remember to turn things into percent, we multiply by 100. So this is sort of a measure of the efficiency of a chemical reaction, and that's percent yield. So let's talk about how we figure out what is the actual yield and what is the theoretical yield. Theoretical yield, you're going to have words like calculated, stoichiometry, should be produced. Those are the kind of things that indicate to you that you're going to be talking about theoretical yield. Actual yield is a lot of times given to us in the problem. So when you're given the actual yield, you're going to look for words such as action words, meaning was recovered in the lab, was produced, measured after the lab, so on and so forth. So if you're given the actual yield, you're going to be looking for some sort of action word to indicate that you've done a lab and this is what you measured as the product of the lab when you were done. The other possibility is if it's not given to you, you are actually in a lab situation. So the actual yield will be what is in your weigh boat when you measure it when the reaction is finished. So those are the kinds of words that you're going to expect to see, and you're just going to have to practice picking out which one's the actual yield and which one's the theoretical yield. If you calculate it with stoichiometry on your piece of paper, that's going to be your theoretical yield. So let's look at what a problem might look like. We're going to first introduce percent yield as it relates to stoichiometry. Next, we'll add in limiting reactants. So the percent yield part of the problem is not going to be the part that actually gives you issues. That's just actual over theoretical times 100. So that's the type of math that's not going to give you problems. The only thing that's going to be difficult to pick out is which numbers do I use where. Okay, calcium carbonate is decomposed according to the following reaction. So calcium carbonate is CaCO3. It is an ionic compound and it is solid at room temperature. Calcium carbonate is something that you see all over the place. If you see a parking lot that has rocks in it that are white, that's probably calcium carbonate. If you have a teacher who uses chalk in your classroom, that's a lot of calcium carbonate in there too. When you heat it, you get calcium oxide and carbon dioxide gas. The problem states, what is the theoretical yield of calcium oxide if 24.8 grams of calcium carbonate is heated? And then it says, what is the percent yield if 13.1 grams of calcium oxide is produced? So we're going to have to calculate the theoretical using stoichiometry. Then we're going to compare the actual that is given to us in the problem with the theoretical we calculated using stoichiometry. So stoichiometry is what we would use if we were doing a stoichiometry problem with one given of one reactant. A BCA chart is what we would use if we were given two reactants, two givens, and it's a limiting reactants problem. This is stoichiometry. So first I'm going to change grams of calcium carbonate to moles of calcium carbonate. Then I'm going to change moles of calcium carbonate to moles of calcium oxide. And then I'm going to change grams of calcium oxide from moles of calcium oxide. You'll see that I'm calculating with stoichiometry that there's 13.9 grams of calcium oxide produced. Now that I have my theoretical, I can compare it with the actual that's given to me in the problem. So actual yield was 13.1 grams of calcium oxide given to you in the problem. Theoretical is 13.9 grams of calcium oxide calculated using stoichiometry from the given. Multiply by 100 and you get a percent yield of 94.2%. Rules of significant figures apply. Our givens are 3 sig figs, so our answer will be in 3 sig figs. Let's do one more. When 84.8 grams of iron oxide reacts with an excess of carbon monoxide, 54.3 grams of iron is produced. So here's our chemical reaction. We're going to start by changing 84.8 grams of iron oxide to iron. I'll do that using stoichiometry. First, I change grams of iron 3 oxide to moles of iron 3 oxide. Then I change moles of iron 3 oxide to moles of iron. And then I change moles of iron to grams of iron. So if everything went perfectly according to stoichiometry, I should have produced 59.3 grams of iron. The problem told me that I actually produced 54.3 grams of iron. So I'm going to plug them in, multiply by 100, and answer to 3 significant figures. And my percent yield is 91.6%. So this is percent yield as it relates to stoichiometry. And we'll fill in percent yield as it relates to limiting reactants tomorrow.